Dynamic programming has a reputation for being hard, but it's really just one honest idea. If a problem breaks into smaller versions of itself, and those smaller versions repeat, solve each one once, and remember the answer. Today, the 2 signs of a DP problem: memoization, tabulation, and a real optimization example. 2 ingredients tell you a problem is dynamic programming. First, optimal substructure. The best answer is built from the best answers to smaller subproblems. Second, overlapping subproblems. Those smaller pieces show up again and again. When both are true, plain recursion wastes enormous time redoing work, and DP fixes it by storing each subproblem's answer the first time you compute it. Take climbing stairs. How many ways to climb and steps taking 1 or 2 at a time? Each call branches into n-1 and n-2, exactly Fibonacci's shape. Here's the tree for 4 steps. Notice climb of 2 appears twice, and climb of 1 even more. Those repeats are the overlapping subproblems that dynamic programming exists to eliminate. The top-down fix is memoization. Write the natural recursion, then cache it. Climb of n is climb of n-1 plus climb of n-2, with base cases at the bottom. Add functools.cache, and every subproblem is computed exactly once. Exponential becomes linear. This is already dynamic programming. You just approached it from the top. The bottom-up version is tabulation. Instead of recursing down, build up from the base cases in a loop. Start with the answers for the smallest steps, then each step is the sum of the previous 2. No recursion, no calls stack. And since we only ever need the last 2 values, we can drop the table entirely and run in constant space. Real DP shines on optimization. Coin change. The fewest coins that make an amount. Build a table where each entry is the best answer for that amount. For every amount, try each coin and keep the smallest count. Each subproblem leans on smaller amounts you've already solved, optimal substructure, and overlapping subproblems working together. How do you spot a DP problem? It asks for a count, a maximum, a minimum, or whether something is possible. You can define the answer in terms of smaller inputs. And a brute force recursion would revisit the same states over and over. When you see those signs, reach for a cache or a table. If subproblems never repeat, plain divide and conquer is enough. Dynamic programming is just recursion that refuses to forget. Spot the overlap, store the answers, and exponential collapses into linear. We've been caching results to save work, but what happens when the cache can't hold everything? Next up, we build the LRU cache, constant time lookups, with a smart rule for what to evict.